Okay, so you are given mathematics for achieved, and you are to simplify and add or subtract like terms in an expression. Normally, they might have simplify this expression. Okay, now if I've got a and I add another a, so we'll take away the ones in front because you don't usually write the ones in front, called the coefficients. If I'm adding, trying to find an simplify an expression like a plus a, I'm adding I can add like terms. Now, if the letter is the same, in this case, the letter is the same, and they're separated by some sort of operator like a plus or a minus, um, if the letter is the same and the power, so this is a to the power of 1, and this is a to the power of 1, if the letter is the same and the power is the same, you can add them together. So I can say, okay, that is a to the power of 1 plus a to the power of 2. That means I have 2 a's. So I can add them together if the letter is the same and the power is the same. So over here I've got my expression. I've got 2 a's, which is the same as writing that. See, that's how I got that. So I've got 2 of them now. And can I add another one? This is to the power of 1, and this a is to the power of 1. So as long as the letter's the same, don't worry about the number in front of them, because remember, the number in front of this, it just represents that there's 1 plus 1 of them added together. So that there is just the same as that, which means I could have written it like this, couldn't I? So it's the same thing. All I'm doing is simplifying that to make it more simple by saying there's 2 of them. So if the letter's the same and that number in front, remember, isn't important. If the letter's the same and the power's the same, then I can add them. That means I can go, yep, there's actually 3 of those. Or I could subtract. I could go, I've got 2 of them and I'm minus 1. So I'm going to end up with only 1 left over. So I can add and subtract if the letter is the same and the power is the same. Let's have a look at an example where it's not. So I've got, over here, I've actually got a more simpler one. So I've got an A and I'm trying to add a B to it. Can I? No, the letter's not the same. A and B are completely different letters. So you can't, so the only answer you can get if you have this as a question is you can say, well, that's A plus B can't be simplified any simpler. It is just A plus B. And the same goes for this one here. If I've got 2 A's, remember that's just the same as saying A plus A. Got 2 of them. And I've got 2 B's, which is the same as saying B plus B. Can I simplify them? Well, is the letter the same? No, which means you only can say there's 2A plus 2B. You can't get it any more simple. Okay, so what is the rule? Remember, the letter has to be the same and the power has to be the same. All right, so that leads us to, we'll do another one and then we'll do some harder ones so you can actually see, because these are easy peasy. So here we have, I've already put the answers down for you, so it's not supposed to be complicated. Okay, I've got 5 of them. Remember, I could have written them out like this 5 times. Okay, could have done that, but I just simplified it easy. There's 5 of them, and I'm minusing 2 of them. Remember, I could have written this out like this. Yeah, but I'm not. I'm writing 2. So if we've got 5 of them, and I'm minusing 2 of them, there's going to be 3 of them left. Do you notice that the letter and the power is the same in the answer? So that's to the power of 1, and that's to the power of 1, and that's to the power of 1. So the letter in the answer, when you're simplifying an expression, the letter and the power doesn't change. You don't add the powers together or anything. They stay the same. But what is changing is called the coefficient, the number in front. So if I wrote it out like this, like really long, really not simplified. So I wrote that out, and instead of writing 5a, instead of writing that, I wrote 5 of them. And then I said, yep, I'm going to add another, subtract another 2 of them, subtract 2 of them. Yeah, so I've got 5 of them here, and I'm taking away another one, then taking away another one. I'm going to end up, aren't I, with how many? I'm going to end up with 3 of them left over, which is easy to write. Just simplify and say, well, there's 3 of them left over. So that's why the number in front, the coefficient, is basically what we're changing. Okay, so let's try. Now I'll draw one out so it makes a little bit, so you can see it. Just move that out of the way. Gonna try and finish this quick as I can. Okay, so here we go. So what happens if I've got a different power? So if I've got a, that means it's a to the 1, okay? Got to be careful. Got to remember there's always a 1 there. If there's nothing written there with the letter, then it's a 1 by default. But what happens if I'm going like this? A plus a squared. All right, can I add them together? All right, so the letter's the same, tick, but the power to each letter is different. So can I add them? No, you can't. So your answer would be a plus a squared. Same as like adding a plus b. You can't add them together. You can't add them together. If the exponent there, or power exponent index, is different, then you can't add them. So what happens if I change it and put a 2a? Can I add that with an a squared? Can I add them together? Well, they've both got 2's in them, but this is to the power a to the power of 2, whereas this is saying there's two a's. This is the same as saying a plus a. Okay. This is saying that's the same as saying a plus a, whereas this is the same as saying a times a. So they're not the same. This here, a times a, is simplified to a squared. Whereas this, a plus a, is simplified to, there's 2 of them. So you can't add them together or subtract them, because they're totally different. This is a times and this is a plus, but this is using pluses. So you notice the power is 1 there. That's a 2. So all we've left with, we try to simplify this, is we're left with 2a plus a squared. That because the letter's the same, but the power's different. Okay, hopefully that makes sense. Now I'm going to mix it up a little bit, make it a little bit harder, because it's always good to try and make sure you really get it. All right, and then I'll do a long one. So if you can do the long one, then you 100% know what you're doing. Okay, so say I've got 2a to the power of 3, and I'm adding a to the power of 2. Can I add them together? No. The letter's the same? Good. Power is different, so you can't add them. Okay, so we'll go like this. 2a squared plus 3a squared. Okay, can I add these or add these together? Well, I've got same letter, a squared, but and the same power, 2. So can I add them together? Yeah, I can. And all I do is add the 2 and the 3 together to give me, there's 5 of them. And there's 5a squareds. Yeah. Notice the letter and the power haven't changed. The number is at the front, that number at the front, the 3 and the 2, that's the only thing that's changing. When you're simplifying by adding or subtracting like terms. When you're simplifying, adding like terms, you're dealing with the number in front every time, okay? This number here, the 2, remember, it's not ever changing when you're adding or subtracting. So when you're adding or subtracting, the only thing that's changing is the number in front, called the coefficient. The powers never change. Just remember, you always end up with an a squared if you're adding a squareds together. Okay, and let's try, as I said, the really hardest type of one you'll get, and see if you can work it out. Okay, so if you can do this one, you've got the idea of it, and you can completely get 100% in a test when you're adding or subtracting, because it'll be like easy peasy. Okay, so I'm going to work with x's this time. So I've got 3x's plus an x squared minus x plus 5 minus a. Okay, so you're asked to simplify this really long expression. Okay, now what I want to do is I want to look for my terms. So let's just separate all the terms. How many terms have I got? How do I know which are the terms? The operators are in between. The pluses and minuses are in between. So I've got one term there. I've got one term there. I got one term there, one term there, and one term there, and one term there. Okay, so I want to separate I want to make sure I know all the terms first. That'd be the first thing. Now I want to look at each one, and I'm going to look right through and see if any of them match. So this is, I've got 3 x's, and they're all to the power of 1, remember? So I'm looking for the letter x to the power of 1. So is this x to the power 1? No. Is this x to the power 1? Yeah, it is. There's an x to the power 1 there. So it's saying there's 3 of them, and this operator here belongs to that x. So I'm going, this has got a plus in front of it, it's just not written. So I've got 3 of them, plus 3 of them, 3, and I'm minusing one of them. So what I'm going to be left with is going to be like 2 x's left over there. Right, so I'm looking at that one, x to the power 1 and x minusing 1. Now, is there any other x's along here I can add or subtract? No. So let's just cross them out that we've done that one. All right, cool. So I've simplified, I've looked along and looked for any that is x to the power 1, and there was only 2 of them, that was lucky, and there's 2x. Okay, now I'm looking at this one. I've got an x to the power of 2. Is there any other x's to the power of 2? Nope. So basically I've just got to add the plus x2 because nothing else I can do. Can't do anything with that one. Can't simplify it. So I can cross that one out. Right, I've got a 5 there. Is there anything else that's a number by itself that I can maybe add or subtract to? Another one where it's a number by itself? No. So it ends up being just 5. Remember, if there was a plus 10 on the end or something, then I have 2 numbers and I could actually add or subtract them together to simplify them, but there's only one number by itself. And I've got an a. Is there anything else with just an a? Nope. No. Okay, so basically you end up with a simplified expression like this, and there's your answer. It can't get any more simpler than that. Normally we order it where the one with the greatest power goes first, and then the one with the second greatest power goes second. So normally I'd write it like, if I was doing a test, I'd write the x squared first because it has the greatest power, or exponent they call it, and so that's a plus x there. This has got all plus in front of it, it's just not right in, so we'll just put that next. Plus 2x, and on the end we have I forgot the minus a. We've got a plus 5. Normally I put the numbers with no letters at the end, so I'll do the minus a next, and if it's just a number we either minus or plus it. So there that would be the best one we could get to. The only thing we could really simplify was these two, really. They were the only ones we could really simplify. So really, the rest of it stayed the same. Now you could end up with some way harder ones than this, but just think through really logically. Look for separate the terms. You could even do what I've done, just put them in boxes with the operators, the plus and minus in between, and then go along and work out which ones you can add or subtract, and then find out and write them down, then simplify them, put them in a nice order, and that would be your answer. Okay, so anyway, that is adding and subtracting like terms. Hopefully that makes sense. If I'd done another harder one like 3x squared plus ax plus x minus a. Okay. Now you might be tempted to go, oh, there's an a there to the power of 1, and there's an a there to the power of 1. So I'll do something with it. Well, a by itself like that isn't the same as when a's with something else. Okay, they're not the same. This here's, they're sort of joined together a little bit, which means that x there, I can't do anything with that x there because this has got an a with that x, so that we can't do anything with that one separately. Okay, this here has to be the same. So if we so if I wrote 3x instead of 3x squared, we still couldn't do anything with that a and that x because this is just x by itself, and this is an a with an x. Okay, so anyway, there's a few little complicated little bits you've got to sort of work through, but I think if you are careful and methodical, as long as it's got the same power and the letters are the same, so don't get confused with thinking a plus b plus AB are the same. Okay, they're not the same. They're definitely not the same, but that there is not the same. They're all of these are different terms. Okay, that's a term, and that's a term. So they're all different terms. So you got to look at them as terms separated by the plus and minus. So that there, B and A, they're totally different. And that AB is totally different. They're not the same, okay? So anyway, that's adding and subtracting like terms. Hopefully, I'm really hoping you really got the idea of how to add and subtract like terms, and that's part of achieved for algebra. So I'm going to move on to the next achieved sort of thing, and hopefully you've really sorted it now.